All right, everyone. So in this example, rather than deal with an object that's moving left or right, we're going to be dealing with an object that's moving up or down. So in this case, we have to account for gravity as well. So a rope is used to lift a 45-kilogram toolbox to the top of a ladder. If the toolbox accelerates at 0.75 meters per second squared, what is the upward force applied to the toolbox? Well, if you're lifting up on the toolbox, then we need to consider the forces that are acting on the toolbox. So here we have the 45-kilogram toolbox, and we have the force of the person lifting up on it, as well as the force of gravity pointing downward. In this case, the force of gravity on that 45-kilogram toolbox is just the weight. In order to determine what the upward force applied to the toolbox would be, we have to consider that the sum of the forces is equal to the mass times the acceleration. We know the acceleration, we know the mass, and we know the weight. And from that, we can calculate the force. So here we're just saying that up is the positive y direction. And we can use Newton's second law, that the sum of the forces is equal to the mass times the acceleration. So since we're taking up to be positive, F1 is positive and the weight is negative. So F1 minus Fg should be equal to m times a. And the force of gravity is just m times g. And so at this point, we kind of have two choices in the way that you solve it. The first one I'm going to show you is, in my mind, the shorter way. And then the second method is the more direct way. So if we move mg over to the other side and set F1 equal to those values, we can then factor out the m and solve. We know the mass, g, is 9.8 plus the 0.75, and that will give us the force, the upward force of it being lifted, of 474.75 newtons. So one thing I'd like to point out here real quick is that when we plugged in g, it wasn't negative. That's because that negative is here. You have to be careful that you don't account for the signs twice. So by saying that the weight points downwards, then we need only say that it's minus because it's downwards, and then the magnitude of the weight, m times g. In this case, g would be positive. The other way to think about it would be let g be negative 9.8, but make this a plus because it's a sum. Either way, you're going to find that you get this answer. The more direct way of solving it is just to plug in the numbers from the beginning and then solve that way. And that will still give you that F1 equals 474.75.